So from here, no, if we will have a bit of a review, no, on parallel connected capacitances, no, this is what we will probably learn. But first of all, no, these are some principles that governs, no, parallel connected capacitances. No? So let me summarize it. No? So parallel connected capacitance. The first principle that we know is that, no, so number one is all the voltages. So we call the voltages V total. No? The total voltage is, of course, the one that we see, no, on the supply side. No? So this one with letter V and with an arrow. This one is your total voltage, no? So that comes from the battery. We realize that it is equals to V1, it is equals to V sub 2, it is equal to V sub 3. No? And if there are other capacitances connected in parallel as well, then we have equal voltages to all of them. No? So one battery and they share the same voltage, no, with all the connected, no, capacitances in parallel. Now, we limit that to 3 because tatlo lang din ato nakakonect. Number 2, we also know that the capacitance total also, no, or no, the charge, no, the total charge. No? So Q sub T is our total charge. So the total charge which comes from our battery, so we have a charge here coming from the battery. And again, this one will go to the different, no, capacitances. So the charge eventually splits, no, into 3 different directions. And what we know is that if it splits, no, then all the values of this of this charge is simply the sum. No? So ang charge nga makadto sa capacitor 1, no, will have the first charge Q1. If you add it up to Q sub 2 and Q sub 3, they will simply be equivalent to the total charge that comes from the battery. No? So our Q sub T is the one that we see here now that comes from our battery. No? So this is where our Q sub T comes from. So Q sub 1 is the one that will enter the first capacitor. Charge 2 is the one that will enter capacitor 2. And Q sub 3 is the charge that will enter capacitor 3. No? So konting bond sila, no? It's equals to Q sub T. Now, we also know that each of these capacitances or capacitors have their own capacitances. That the total capacitance, no, C sub T, so C sub T is our total capacitance of the circuit. It's equals to C1 plus C sub 2 plus C sub 3. No? So these are the 3 governing principles now of parallel connected capacitances. So i-add lang, no, ang tanan niya capacitance it will be, no, equal to C sub T. So if you will again, no, give values, so V sub T is our total voltage, no. So V1 is the voltage of capacitor 1. No? Okay, and so on with V2, V3. No? Our Q sub T is our total charge, no? And this is expressed in coulombs. So Q1 is our charge 1 for capacitor 1. So Q1 is next, our C sub T is our total capacitance. And the capacitance is in farad, no? And C sub 1 is, of course, your capacitance of Okay, so these are things that maybe now you have to understand, no? Some symbols that we have to understand. So again, now I simply limit it to C sub 1, Q1, but there are other notations there, no? So if this is the one that governs parallel connection, how are other, no, circuits formed? No? So we have another kind of circuit, and we call the other circuit a series connected, no, capacitance. No? So may ara, pahigita nga another connection. We call it, again, no, series connection. Now, for series connection, the capacitances are connected, no? Uh, from one terminal, we connect the next one, no? Next device. And then the other terminal of the other device is connected to the third, no? Capacitance. So therefore, we can call them as capacitance 1, no? This first on the left. The middle is capacitance number 2. The third is capacitance number 3, no? Now, what we find, no, in series connected capacitances, no? If series, no, is of course a different connection. So in series connected capacitances, the first thing that we will see here is that the charge, no, total charge is equivalent, no, to the individual charge, no. Ang charge naman niya ang parehas all throughout, no. Siya naman ay ang parehas. So this is the first principle, no. Now how did we know that the charge is the one that is the same, no? Now you'll realize that from the source, no. So here is our source, no. Let me encircle it. So if this is our source voltage, no, this is the battery. The battery is connected, no, from this end to the other end, no, from the first capacitor to the third capacitor, amo na iya connection. And if you'll notice, no, if the charge, no, and if you connect these capacitors to the battery below, you'll realize that if this is the total charge here, no, that comes from the battery, it will now enter, no, the circuit, no, starting with capacitor 1, leaves it, no, and then again goes to capacitor 2, and then again leaves it and enters capacitor 3, and then again leave it again and enter going back to the battery, no, mabalik na siya sa battery. So the distinction is that, no, if this is Q sub total, this is the total charge from the battery, and then here comes your other charge Q1, no? And here's another charge Q sub 2 over here. Then there's another charge Q sub 3 here, no? Na masulod sa capacitor 3. You will notice nga, kung ano ang charge na nagsulod sa capacitor 1, magwa lang na siya unchanged, no? Kaya wala man siya nag-split, no? Wala siya gintunga. It is simply entering the capacitor and then leaves it, no? Enters the second capacitor and then again leaves it, and then eventually returns to the battery, no? And the one that will return to the battery must be Q sub T, no? So kibali do nag-agi lang siya sa isa ka tangke, pero naglabay lang, no? So ano ang nabilin da? Hindi pwede mabilin ang mga charge, but ang mabilin lang da niya ang energy, no? So as the electrons passes there, or the charge, no, it eventually, no, leaves that capacitor once it is fully charged and then proceeds to the next one, no? So the charges there are equal, no? But however, no, what we see also, our next principle is that, no, ang ilan nga voltages, no, mo naman ang aton nga is sum up, no? So the total voltage is the sum of the individual voltages, and then the third principle is that, no, ang aton nga total capacitance, no, is in terms of a ratio, no? Okay, so ma-ratio na siya. No? So as to the question, why is it a ratio? So 1 over C total no, is equals to 1 over C1, 1 over C sub 2, 1 over C sub 3. No? And again, the reason for this is that we always go back to equation 2. No? So if our general equation is, kung mag-solve kita sang V, no? If V is calculated as Q divide by C, that's the equation of our V, no? Then we will realize nga kada V value dito sa number 2, pwede natin masulat as, so ang V total, our V total could be written as Q sub T, no? All over C sub T, no? That's for equation 2, no? Our V1 is Q1 divided by C sub 1, no? And then our Q sub 2 divided by C sub 2. What value is Q2 over C sub 2? What is this value equal to? If you divide Q sub 2 with C sub 2, that's equals to our V2, no? So again, kung i-divide mo ni sila, if all of these are being divided, ang maning equals sa aton nga total voltage VT, this is V1, no? Ang Q1 over C1. Ang Q2 over C2 is our V2. And voltage 3 is Q3 over C3. No? And then we have to put a sum here. No? Now from equation 1, however, we realize nga ang mga Q ni, they are simply equivalent to each other. No? So again, by algebra, we can actually all factor it out. No? So kung i-factor out na natin, ang guaya doon man ang Q sub T, pwede natin ma-factor out in such a way nga man Yan, karon ng expression nga 1 divided by C sub T. No? Kaya factor out natin ng Q sub T. No? Tapos if Q1 is equals to Q2 is equals to Q3, it is equals to Q sub T. Then ang mabilin sa sulod, no, if we factor out Q1, Q2, and Q3 equals to Q sub T, nakakaroon ng 1 over C1, 1 over C sub 3. No? Ang manikaroon ng mabilin sa mga expression dire, no? Again, no? Formulating that. Now, if Q sub T is found on both sides of your equation, then you can cancel it, no? And then eventually, ang gwa sa aton equation now, no? Ang mabilin na lang equation is similar to this one, no? Ang mabilin, ang manani, no? So this is now our principle number 3, no? So it is a reciprocal, no, of the individual capacitances ang total capacitance. How different is our series from parallel connection? Again, if we are going to detach one component of our series connected device, the whole device, no, or the whole circuit will not work. Isa lang ang hukson mo da, no? The whole circuit eventually suffers. No? So that's how different is series from parallel connection. No? So it's much more sensitive. No? So here's an example. No? 3 capacitors have capacitances 1 farad, 2 farad, 3 farad. No? So perhaps this is Q1, C1, C sub 2, C sub 3. And they are all connected in parallel, no, to a 12-volt potential difference, no, or a battery. No? So we are asked to find the charge in each capacitor. No? So of course, if it is parallel connected, no, if it is parallel connected, we know that the total charge is, no, or the total capacitance. We can actually calculate the total capacitance there. No? So for letter A, if you'll try to calculate this, no? So the total capacitance, first, if it is in parallel, no? So basically our equation is C total is equal to C1, C sub 2 plus C sub 3. No? So that is merely equivalent to 1 plus 2 plus 3. No? And that is obviously 6 farad. No? So the total capacitance. No? But no, sorry. No? What is being asked gali is the individual charge. No? So it's not total capacitance, I mean. No? So if you are to calculate the individual charge, so Q1, no, or yeah, Q1, no. So let's try Q sub 1. So Q sub 1, we solve Q sub 1 by multiplying C1, V1, no. And again, if they're in parallel, the voltages are simply equivalent. So this is equals to 1 farad times 12 volts, no. So your Q sub 1 is, of course, 12 coulomb, no. So capacitance times voltage. So for Q sub 2, it's C2, V2. Now, what is our voltage if it is parallel gani? What are the voltages if it's in parallel? The voltages are what? Are equal. No? So, dapat 12 manigyapon din. No? So, 2 times 12 gives you, this must be, 24 farad. No? And then Q sub 3.
Hindi, sir, coulomb, sir. Ang 24.
Sorry.
Coulomb, sir?
It is in coulomb. No? Next, Q sub 3 is, again, C3, it's 3 farad, no? Times 12 volts gap 1. That gives you now 36, no? Now again, a 1 farad value is a huge value. So in real terms, we do not use it as is, no? So again, we do not use that exact value. Now, if you will go for a series connected, no? What we know is that the charge in the capacitance are all the same, no? So one thing we know for series, no? If it is series, we know that Q sub t equals to Q1 equals to Q sub 2 equals to Q sub 3. So we need to know only one value here, no? So maybe, if you try to solve for Q sub t, we solve Q by dividing voltage. We divide the voltage by the capacitance, no? So we will probably need total voltage divided by total capacitance, no? But our problem is, how much is our total capacitance? Again, the total capacitance is 1 divided by C total. It's equals to 1 over C1. So if C1 is 1 farad, no? Our C sub 2 is 1 over 2. 1/2, bale. And our C sub 3 is 3 farad, no? So 1/3 man eh. So we'll be adding first, no? 1 over 1 plus 1/2 plus 1/3, no? But again, the answer of these three fractions is not still not the value of the total capacitance, no? So that is still a reciprocal value. So 1 over, no, C total. Paano mag-add ng fraction? So if you will make them, no, parehas ang denominator. So if you will have here a value, we'll have a common denominator of 6, no? So 6 divided by 1 is 6. So definitely our numerator here will be 6, no? If you divide 6 by 2, that's 3. If you divide 6 by 3, that gives you 2. So 6 plus 3 plus 2 is, pila na? 9, 11. So this basically the equivalent fraction here is, so our fraction here is equal to 11 over 6, no? But that's not the answer, no? Ang 11 over 6. So C total, para makuha mo, then you have to reverse, no? 11 over 6 by dividing 6 divided by 11, no? So pila ang 6 divided by 11, no? How much is our value there, no? Our answer is 0.45, no? Again, no? Ay, sorry.
54 gali sir, 0.54.
0.54. So this is in farad pagyapon, na. That is still in farad. Now, this is your value of the capacitance. So if we will try to solve for the charge, guys, no? Pabalik naman kita di sa baba, no? Now, we know that the total voltage is 12 volts, no? If you divide that by 0.54 farad, ilaton sa bat. How much is our answer here? 12 divided by 0.54. Can somebody solve for that? So, madouble siya roughly. Mga 20 plus.
22.2.
22.22 sir.
22 point.
22.
22.
Tama na. So, this is in Coulomb, no? Now, try to know, anong natabo sa aton nga total charge, no? Ano pang ginasapangita? Individual charge gali, no? Our total charge, no, which is equals to Q1, Q2, Q3, medyo nagdubo siya, no? Because of the way the capacitances are connected, no? But we have a if you'll get the total charge for parallel connection, no, and we believe, no, it's going to be a little bit higher, no? But for series, no, ang total capacitance natin is a bit lower, no? Okay, so this is how we calculate, guys, no, the circuit, no, that we have, no?